Welcome to tonight's deep dive. If you're settling in right now, maybe staring at a dark-themed IDE, just kind of wondering where this whole industry is actually heading, well, you are in the right place.
Yeah, we're getting into some really fascinating territory tonight. We're pulling from the LLM Mastery series,
Yes.
specifically their notes on the future of agents. And the mission here is to really, cut through all the social media hype.
Right, because there is so much hype.
Oh, absolutely.
Yeah.
We want to actually decode how AI is transitioning from just answering our questions to actually doing the work right alongside us.
Yeah, so just imagine a world where you never have to wait for another team to build an API endpoint ever again. I mean, it sounds like a complete dream,
It
right?
really does.
Like, normally you need to pull data from some legacy tool, cross-reference it with a SaaS platform, dump it in a dashboard that's, 3 Jira tickets, a cross-functional alignment meeting, and like a 2-sprint wait.
At least 2 sprints.
Yeah.
Yeah.
Right. But instead, the idea is you just open a prompt, hand the objective to an agent, and go grab a coffee while it just, visually navigates the tools and does the workflow itself.
It is the ultimate developer
Yeah.
fantasy. But the thing is, if you look at the architectural leaps happening right now, especially with computer use models, we're rapidly crossing that threshold. We are moving past passive autocomplete tools into this era where AI operates as an active, autonomous worker.
And we really need to map exactly where we are on that timeline today, because we aren't quite there yet, right? Like, there's an evolutionary ladder here.
Right, exactly. The source material maps out this agent maturity spectrum, and it essentially has 3 distinct rungs.
Yeah.
And to understand where you're going, we have to look at where we are. We are currently basically crossing the bridge from rung 2 to rung 3.
Okay, so let's relate this to like a software engineering career path for our listeners. Roan 1, that's basically the reactive chatbot. It's basically a highly conversational search engine, like asking Stack Overflow. You ask a question, it gives you a code snippet, and boom, the transaction is over.
Totally stateless. It has zero initiative. It just sits idle in memory, processes your prompt, and then its job is done. There's no sustained action at all.
Yeah, and then you sneak up to rung 2, which is the supervised assistant, and this feels like where we're living right now.
Exactly.
It's like pair programming with a really fast junior dev. You write a comment, it suggests a block of logic. You run a test, it fails, and the assistant suggests a fix.
Right, but the key constraint of rung 2 is that tight loop. The model has, a very limited form of agency. It can read your file tree, but you, the human engineer, are still totally driving the car. You are supervising every keystroke.
Right, you're the one hitting tab to accept the code.
Exactly. It's a reactive loop. But rung 3, and this is the big leap, rung 3, is autonomous agents.
Okay, but wait. Are we really saying we're about to just, like, hand a Jira ticket directly to the AI and just walk away?
That is the goal of rung 3. And the architectural shift to get there is monumental. You can't just rely on next token prediction anymore. To free up an engineer, the system has to operate while you're at lunch.
So it's not just generating code.
No, not at all. It requires a complete execution loop. Things like the React framework reason, act, where the agent has persistent memory, it has a scratch pad, it has to formulate a plan, execute step 1, observe what happens, evaluate it, and then decide on step 2.
Man, the cognitive load on the model for that loop has to be just massive. Like, if it takes 50 steps to do a database migration, its context window is just filling up with all its previous actions and, like, terminal errors.
Oh, yeah. It has to remember its original objective while it's deep in the weeds of, step 42, fixing some random dependency error. Yeah. It's a continuous loop of perception and action.
Which brings up a really massive question. If these rung 3 agents are operating autonomously, formulating plans and executing them, how are they interacting with the software ecosystem?
Right, because there aren't APIs for everything.
Exactly. The real world runs on digital duct tape. You've got 20-year-old internal tools,
Wow.
third-party vendor apps. There's no beautiful REST API for most of that.
And this is where we hit the core breakthrough from the deep dive notes. Computer use and browser agents essentially eliminate the API bottleneck entirely.
Okay, wait. How?
Well, the premise is simple. If a human can do a process through a screen using a keyboard and a mouse, an agent can, in principle, automate it today.
Okay, look, I have to channel the skeptical engineer here. We have had screen scraping and UI automation for decades, like Selenium, Cypress, Puppeteer. and it is famously aggressively brittle.
Oh, it's a nightmare.
Right. You write a script looking for a specific CSS selector to click a checkout button. The front-end team updates the framework. A div class changes from like BTN primary to BTN blue, and the entire pipeline just violently breaks. Production grinds to a halt. Are we really saying the UI is the new API? Because that sounds awful.
I mean, that skepticism is totally justified if we were still talking about DOM scraping or rigid scripts. But the material emphasizes we aren't doing that anymore. The leap here is driven by vision language models, or VLMs.
Okay, so they aren't parsing HTML?
No, they aren't looking at the underlying code to find a CSS class at all. They are visually processing the screen, literally the same way you do.
Wait, really? So it's looking at the actual rasterized pixels?
Yes. Think about it. When you look at a new web page, you don't inspect the DOM to find the submit button. You just understand the visual hierarchy. You see the shape, the text, the contrast.
Yeah, I just look for the blue rectangle.
Right. And VLMs do exactly that. They take continuous screenshots, break the interface down into a spatial grid, and generate bounding boxes around the interactive elements.
Oh, wow. So it functionally understands the interface visually?
Yeah,
And then it just computes the X and Y coordinates to move a virtual mouse and click.
exactly. So if the design team completely rewrites the app and changes every single class name in the code, but visually there is still a blue button that says submit,
The agent doesn't even care.
it doesn't even notice the code changed. It just finds the shape and clicks it. It completely bypasses the need for developer-built API integrations.
That is insane. I mean, that makes literally the entirety of the digital world available to automation. Even that ancient mainframe emulator the accounting team uses.
Yep, if it's on a screen, the agent can use it.
But okay, if the technology can visually navigate a screen like a human and execute multi-step plans, why isn't it running the entire world right now?
Because I've seen the Twitter demos.
We all have.
Right. An agent opens a browser, finds the cheapest flight, fills out the details, books the ticket in like 30 seconds. It looks perfectly solved.
Yeah. Well, building a demo is easy. Building for production is a complete nightmare.
Huh. It's the ultimate. It works on my machine.
Exactly. The source notes hammer this point home. The reliability gap between a flashy demo and actual chaotic production environments is the single biggest barrier to agent adoption today.
Because a demo is just a happy path script, right? The website loads instantly, no pop-ups, network latency is 0, but the real world is chaos.
Oh, yeah. You deploy that flight booking agent in the wild, and suddenly the airline website throws some random A/B test pop-up that shifts the layout. Or there's an ad for a credit card completely blocking the checkout button.
And a human handles that effortlessly. We just hit the little X on the ad and move on.
Right. But for an agent,
For an autonomous agent, teaching it to handle that infinite long tail of edge cases is brutally difficult. The complexity of state management is staggering. When it takes an action, it alters the state of the world. And if its perception is even slightly off,
like it thinks the page loaded, but a background API call is actually still hanging?
yes, then its next action fails. And those errors compound so fast, it clicks a button, gets an error modal it doesn't recognize, hallucinates a fix, clicks something else, and suddenly it's completely lost in a state it can't recover from.
Wow. Yeah, I can see how that just spirals out of control.
Which is why closing this gap requires years of hard engineering. It's not a patch coming next week.
So, because that production environment is so chaotic and the reliability gap is wide, we obviously can't just unleash these RUM3 agents into corporate networks overnight.
Oh, absolutely not.
Right, like as engineers, how do we actually build a leash for an AI? Because giving an agent full autonomy feels like giving root access to an intern. How crucial is a kill switch here?
It is mandatory. The methodology here is that trust is earned incrementally.
Yeah.
You don't just jump to full autonomy. You demand total transparency first. You have to log the agent's scratchpad, its chain of thought reasoning.
So you need to know exactly why it decided to click a specific button.
Exactly. Deep observability. But alongside that, you need hard kill switches at the orchestration layer. If an agent is assigned a JIRA ticket to scrape a public site, but suddenly tries to invoke a tool call to write to the HR database,
The orchestration layer just traps that call and drops a session.
instantly severs access and pages a human. And that incremental guarded approach is exactly why the near-term reality for our day-to-day workflow isn't full autonomy. It's human in the loop.
Human-agent collaboration.
Right. Agents handle the massive volume of routine tasks, while humans handle the exceptions.
You know, I really like to think of this as standard exception handling in code. The agent is basically running the try block. It handles the predictable workflows, clearing out 80 to 90% of the mundane work, and the human worker. We're the catch block.
That is a brilliant analogy.
We only get invoked when things get weird, or when a task actually requires real business context that the model just doesn't have.
And the sources emphasize that this try-catch dynamic is the optimal design for the immediate future. It maximizes efficiency by offloading the sheer volume, but it protects the business.
Right, because you keep human intuition exactly where you need it most,
Yeah.
at the boundaries of the unknown.
Exactly. But that introduces a really massive engineering problem, which sets up the next frontier of this space. Think about it. If human engineers are acting as the catch block, stepping in to judge the agent's work when it fails, how do we systematically test the try block in the first place? How do we know the agent is actually doing a good job at scale?
Oh, wow. Yeah, because with traditional code, testing is deterministic. You write a unit test, assert x equals y, it either passes or fails. How on earth do you write a unit test for an agent's judgment?
You've hit on what is widely considered one of the hardest problems in AI right now, evaluation. Measuring if an AI system is actually good is incredibly complex because these are probabilistic systems.
Right, there are infinite valid paths. It might complete a task efficiently in a way you didn't expect, or it might take an action that looks fine but breaks a downstream process entirely.
Which is why you can't just use a simple assertion test. You have to balance hard accuracy metrics with automated grading, like using an LLM as a judge to score the agent's execution traces.
Wait, so we are building software to probabilistically score the software that is automating our software?
Pretty much. Creating ELO ratings for models and blending those automated scalable metrics with the irreplaceable nuance of human judgment is the only way we confidently move from rung 2 to rung 3.
Okay, so just to quickly recap this journey for everyone listening tonight, we're moving from simple chatbots to these wild, screen-controlling visual agents. But we're facing this brutal reality of the production reliability gap.
Right. The real world is messy.
Super messy. So the immediate future is human-agent collaboration, the try-catch block. The agent tries, we catch the exceptions, and we keep our hands on the kill switch.
That is exactly where we are. But, there's a final sort of lingering thought the source material leaves us with, and I think it's worth pondering long after this deep dive ends.
Oh, what's that?
Well, we know the near-term plan is for agents to handle the routine try block while we humans handle the complex catch block exceptions. But these browser agents can see exactly what is on our screens, right? They visually process the environment just like us. So what happens when they start quietly observing how you, the human, navigate those chaotic edge cases? If they're watching you handle the exceptions, how long until today's exceptions become tomorrow's new routine?
Oh, man. Wait, really? If these models start training on our exception handling in real time, the transition to full autonomy might happen way faster than we think. That is a wild, slightly terrifying thought to end on.
It really makes you think about your workflow.
It really does. Well, thank you all for staying up late and exploring the architecture of tomorrow with us. Keep your code clean, keep an eye on those execution traces, and we'll catch you on the next deep dive.